Okay. All right, let's continue. Let's continue where we were. This is 1.4 still. And we just finished off. Guys, tell me, what did we just finish off here? We finished off what example again?
Example 4.
4, right? It was, let me recreate it a little bit here. It looked like something like this, I think. Absolute value of x squared, and it looked like this. All right, tell me if you guys agree. Yeah, it had this right here. And it had something that looks like this, right? Anything less than 0, we're going to use this function for it. Any number between, or x value between 0 and 4, we're going to use that function. Anything either 4 or 0, right, or greater, would be use that function. And then we had what, a. And on the notes here, just real quick to make sure we get on the notes here, what is f of -1? Just a 4, huh? And then let's see, did we do this one here, f of 3?
Yeah.
Which we had to use the middle term, which turned out to be 3. And C, that's right. F of 4. And f of 4 turned 13. Okay. Okay, and let's see, how about one more? Just for testing purposes, D, I want to know f of 0. Which function do I use for f of 0? How come the top one? Yeah, this little guy right here, because it's less than or equal to 0, we're going to use the top one, and that's going to be 0 squared plus 3, which is just 3. Okay, cool.
So why would you not use x is less than or equal to 4?
Because we're plugging in 0 itself. And because it's a 0, it falls into this category of less than or equal to 0.
If sorry, if x was less than or equal to 4, I misspoke.
Yeah.
Would we use not or?
That's if x is greater than.
No, I'm saying if it was x is less than or equal to 4, then and x was less than or equal to 0, then you would have.
Yes, you would use the middle one at that point. Cool. All right, let's jam. Example 5, let's go. Example 5, we have to do is just make sure I got mine correctly here. Oh, I'm on the next page here. Yes. Find all values. All values of x. Of x such that f of x equals 0. Again, we're just playing with notation here. And we'll do 2 problems here. So here it is. I want to know when f of x equals 0. Talk to me again. We're out of here at 9:45. Is that right? Okay. No. Answer is awesome. Okay, so we're trying to figure out when does f of x equal 0. And notice what we do is we just replace this guy with 0. So we're trying to figure out what x value would make the resultant 0, which is different to say this one right here, right? This is kind of what they're trying to make you sort of realize. That is, this one's you're plugging in the 0, right? This one you're solving for 0. All right, and I think Noah subtracted 1 from both sides, divided. Perfect, okay. Just did it. Just did it, that's it. No preference whatsoever. Unless you just want to mess with me on the homework. Like, oh, I can get Mr. G. Watch this. I'm going to write it as. Not cool.
I mean, it won't change. I don't think we're gonna get you like that. Then you tell them that he was wrong, though.
All right, all yours. Go for B. Oh man, you guys remember factoring from algebra? Did you guys do factoring in geometry or no? Or not much? Not much. Okay. Yeah, still the same type of problem here. I changed this to a reach. Okay, tell me if you guys are okay there. And then the factoring step. So talk to me about the factoring step. I go like this. No, too quiet. So maybe like this question is, do we need like a day that we actually go over factoring again?
Yeah.
Since we haven't seen it for like 2 years. Maybe. We're saying yes. The box method. Do you guys remember this one from some time ago? Right, like this, and it was let's see, x squared over here. Raise your hand if you hated the box. Hate the box, hate the box. Okay, how many?
It's x minus 3.
Perfect. How many didn't mind the box? It was like, okay, box is okay. How many love the box? Like, this is such a cool thing. Box. No. Okay. Okay, so we have to, these two added together has to give you a -8, is that right? And then you start guessing, because this has to be x, this has to be x for sure, right? That's the only way you can get that. So to get 15, a positive 15, -8, the only way that I could do that is a -3 was here, a -5 was there, and you tested it, right? -5x, -3x, and these two added together, do they give you a -8? And if they did, that means you factored correctly. Good. And so how about x minus 3? X minus 5, and just checking. Does that make sense to you guys? Is that right? That's the box method. I like the X box method. Yeah, X box method goes like this. Right
Is
here.
that where you avoid the Xboxes?
No, definitely not mine. So we know we're going to have an X over here and X over here, right? Because that's the way you get the X squared out, right? So here's the X box method. What you do is you take the 15, you put it on top, you take the -8, you put on the bottom, and here's what you gotta do. Just, it's a guess and check again, but it's a little different system. So I need two numbers, multiply to 15, add to -8, and then you just kind of cycle through in your head, just real quick here. I need two numbers, multiply to 15, add to -8. I know both of them have to be negative, right? -5, -3. It's the same exact process, right? Which I think is just like a little bit less writing things down, I think, in my mind, but maybe. Because you don't have to make the box, then put the thing in the box. But everybody okay with there?
Yes.
Whichever one.
I remember that.
Were you guys ever taught the second method or just the first method?
We were
Both?
definitely
Okay.
taught both of the methods.
Okay, cool.
We just have very long-term memory loss.
So if you got two things multiplying together to give you 0, you can set each of them equal to 0. Okay, there's that. And we got ourselves x equal to 3, x equals to 5. And those are the two answers that we have for that problem. We're good. Do we need to do another factoring thingamajiggy? What do you guys say? I'm going to decide. Yes, it's going to be yes. Ooh, a little bit more complicated here. No, let me give you one that's kind of similar here. Ooh, I'm gonna go like this, like that. That's fine. Yeah, those two are just good practice. All yours for this one, very similar to B, just for practice. And
Yeah, X.
Squared is 9 minus -3. 12 minus 12.
perfect. Okay, so Noah has 3, right? Negative 3.
Yeah.
Cool, but is there another answer? 4, absolutely. So, and kind of just the difference between guessing and checking. Again, I'm going to do my preference is -12 on top, -1 on the bottom this time. So now the question is, okay, because I know this guy's going to factor, I might as well put my x's already where they're going to be. Two numbers multiply -12 adds a -1 has to be -4 +3. -4 +3. Set each of them equal to 0. And can we do this any way faster? What do you guys say? Add 4 to both sides. Subtract 3 to both sides, and finally get my answers is x equals to 4 and -3. Get both. Okay, shortcut. You guys ready? Once you guys do this, is there any connection from here to here? Ooh. Answers. No. They are the exact opposite of our answers, right? So you got a -4, but the +4 comes down.
The answer is 0.
No, the answer is 4, -3.
No, like,
No, the answer is not zero.
Yeah, 4, -3.
the answer that you're looking for is 0, and the answer that you
No,
get there
no.
is 4 -3.
No.
Let's go. Let's stick with 4, -3. Okay, real quick here. That's Xbox, right? There's actually Xbox 360 as well. I gotta show you this sometime. It'll just be fun to see it sometime. Okay.
So it's a free Xbox.
One more for you guys. This one's gonna be a different factoring. All yours. Try this one. This one, if you guys remember from your factoring 4 terms. Do you guys remember 4 terms? How do you do 4 terms? I'll help you out. We good? So if you have 4 or more terms, what we did by factoring, remember factoring by grouping? Do you guys remember something like that? What we do is we go like this. We put 2 parentheses with a plus in between. We good? So this is just for 4 or more terms. But we're going to put the first 2 terms inside the first one. We're going to put the other 2 terms inside the other one over here. And then we're going to do them individually. We're good? So instead of having all 4 to do at once, we're going to do it 2 a little bit at a time here. So what is the greatest number I can pull out of x cubed and x squared? X squared, right? It's going to be the lower one because you still need another multiplier to get x cubed. Perfecto. I get x minus 1. Ooh, what can I pull out of the second parenthesis so it looks just like the first parenthesis? Close. If I pull out a 4, I'm still going to get a negative x plus 1. -4. It kind of gives it away, doesn't it? Because you just left with x over here, you know, you're going to pull out whatever multiplies x. So taking out a -4 out of here, -4 times x gives you -4x. -4 times a -1 gets you a +4. Yep. Okay. Next. Notice the 2 parentheses are exactly the same. So what I'm going to do is I'm going to actually pull out the x minus 1 in parentheses. We're good? So I'm going to go like this. X minus 1 gets pulled out. So now the question is, what's the multipliers that are left?
X squared minus 4.
X squared from this one, and then -4 from this one. Can I do any more other factoring?
Yes.
What is it, Noah?
Pull X out of both of those.
Difference of two squares.
Yes, difference of two squares. X squared minus 4 is
X plus 2x minus 2.
perfecto. Okay, you know what? Let's go a little faster here. Okay, so if my factors are x minus 1, x plus 2, x minus 2, what are my answers?
1, -2.
Thank you so much. They're just going to be opposites, right? Technically, what you're saying is if 1 goes in here, right? 1 minus 1 will produce the 0. And then it's just going to be the answer. We're good. We're good doing it a little short way, quick way. Okay, there's that. That's when it equals 0. Let's do 1 more, 2 more, 3 more types.
Would -2 equal 0 always with this sense?
That's what we solved for. We saw, so if x becomes 1, so now we know this right here. We know f of 1 is equal to 0. We also know that f of -2 equals 0. We also know that f of +2 equals 0. That's what we know. That's what we just solved for. We solved for the input value to give us 0. Okay. Example, what number are we on?
6.
Thank you. Okay, now another question here. Find the values of x for which f of x is equal to g of x. So another type of problem here. And we'll erase this guy. That one's kind of funny. So now what are we saying? We're saying find the x values that would make the f function and the g function to be exactly the same. So f function, here we go. All right, give you guys 30 seconds to try yourself. Go for it. And I'm going to go with that there. All yours. So again, it's just manipulation based upon function notation. That's what this is. Manipulation based upon function notation. You're just trying to figure out what it's asking you to do. No.
No.
Okay. 20-second head start. All yours. Go for it. I'm trying to figure out what values of x. So eventually I'm going to get x equals something or other, right? That this is true. When is that true? Or what values of x give me that to be true? I don't know. But in mathematics, a lot of times we just substitute stuff in, right? Jam, and you are correct.
-1 would not work.
I think it shall. Uh-huh.
No, because I don't think it would, because then it would be 0 on the g of x.
Oh, let's try. Let's try. Let's go for it. So f of x. F of x would be, so what we're going to do is we're going to actually take this piece right here, bring it down here. So the f of x function is x squared plus 2x plus 1. The g of x function is 3x plus 3. And you solve it.
Just 1 is worth, but not -1.
Let's try it. Let's see. So subtract 3x from both sides. Subtract 3 from both sides, right? Whenever I see an x squared in my mind, like this right here, I know I'm going to start factoring most likely. So I might as well pull everything over, set equal to 0. Hey, that's exactly what we did in example 5. Weird. Okay. I'm going to go with Xbox method here. So x goes here, x goes here. I need 2 numbers. Multiply to -2.
Gonna be
Add to -1.
-1.
No.
Should be 2 -1. Or is it -2 and 1?
-2, +1. I like to keep my little plus sign in there too, just because then I know which one's positive, which one's negative. Then they carry over here real quick here. -2, +1. Therefore, I'm going to do the shortcut. I'm going to go +2, -1. Are we good? Yes, that works. Awesome.
If
Da, da,
you
da.
actually plug that in, then it's 1 minus 2 plus 1. Oh,
And it works like a charm. That's so cool.
but then if you plug in 1, it also works.
One will not work.
Because then it would be 6 on the G.
Yeah, 6 for G, but then it's 4, right? 4 for F. Yeah. Okay, let's see. So that was the one that actually required factoring. Let's go with another one. Requires a little bit interesting stuff there. How about f of x? F of x gives us the square root of x minus 4. And then g of x is going to give us 2 minus x. Make sure I wrote that correctly here. All yours. Go for it. Again, 30-second head start. Set them equal to each other. Ooh, this is a fun one. This is from the second or third last chapter you guys had in Algebra 1. You guys still remember that stuff? No. Say again. Sorry, say again. X equals 2. No.
I don't know.
No, because it would be 0 on one side, but then it would be square root of 2 minus 4 on the other. And that would not work. So I think this is the first time, right? Because if it was square, then yes. If it was squared, but not a square root. But that was good guessing, though. So I have a square root of x minus 4 on one side. I have a 2 minus x on the other. And do you guys remember, what did we do? How did we solve this when we had a square root inside our equations? Do you guys remember that? No, it's been way too long.
You
Multiply by
don't
all
you
by
square
x.
everything?
Oh, close. No.
You square everything. Don't you
This-
square everything?
Yeah, the two Noahs got it correct. Absolutely. But before you square stuff, what we do is we want to get this little square root right here all by itself on one side. So before you do that, we're going to move this guy over here. Yep, and we can probably sing that song too.
Same thing with.
Okay, square root is all by itself. Awesome. Here we go. We're going to square this side, square the other. So this side nicely just becomes an x. Ooh, this side. I need to do this maybe on the side here, a little bit here. This is maybe on the side. Ooh, no, it is not. Because it still has a little middle part to it. This is 36. Good job. Yeah, there's a negative 6x and another negative 6x. So negative 12x. And then a positive x squared this time. Is that right?
Then we can subtract x on both sides.
So let me write this in first though. So 36. Everybody okay with 36 minus 12x plus x squared? Yes. I see an x squared now. Bummer. So this point set equal to 0. So I have to move this over. And you know what? I just don't like the way it looks over here. So kind of few things here. This is 13x right here. So first things first, let me just flip it all over across the equal sign. So this x squared goes over here as x squared minus 13x plus 36 equal to 0. Are we good there? We just flipped it. Ooh.
Now, if that was equal to 1, would that then be that you have to flip it? And positive, make it positive on one side and negative on the other.
Yeah, so correct. Yeah, I just kind of flipped it over. I didn't subtract stuff to move them over. I just said, okay, the right side is going to be the left side, and the left side will be the right side.
Oh, okay.
So, all right, here we go again. Two numbers multiply. Two numbers multiply to 36, add to a negative 13. So I put arrows at the end. You don't need to put arrows, but this just kind of to remind me here. Multiply and add, just so I know which ones go where. Sorry, okay, go ahead.
Oh, when -4, -9.
I go with that. Perfecto. -4, -9 works. I can plug it in here, and my shortcut says I do what?
9, 4, 1,
49?
1.
Yeah, 9449. Oh, and then not good, not good. Like alarm goes off in your head, like So no, okay. Let's see. We have this. Well, let's first of all, let's do it this way here. Let's plug in the 9. Let's plug in the 4. Does the 4 work? Yeah, I think it both works, right? Because this would become a 2. 2 minus 4 is a -2. 2 minus 4 is a -2. Does 4 work? No, agree?
Yeah.
Okay. 9, go for it. 9 works as well, correct?
No.
No. What went wrong with our calculation? I don't know. Something about algebra, something about this step right here. Right there. There's our little step.
You multiply by x right there instead of squaring it.
No, you got to square. But here's the thing. Whenever we square both sides of an equation,
It's plus or minus.
no, but close though. That's when we square root of the equation. That's cool. But if we square both sides of an equation, it is possible that we have something called extraneous solutions. Did you guys cover that in Algebra 1?
No.
Extraneous solutions. Ever heard that word before? Extraneous solutions. Okay, extraneous solutions. Say it 5 times real quick. Extraneous solutions, extraneous solutions, extraneous. Okay, guys, real quick here. If you are the one that's squaring both sides of an equation, it could be that these answers are not true answers, they're fake answers. So you have to, here it is. What do you do with extraneous solutions? You have to plug in to check. It works always, mathematics, no matter if it's algebra or calculus, trigonometry, whatever. If you squared both sides of an equation, because you had square roots there, it is very much possible that you have made extra answers that are not really true answers. So you have to plug them in. We plugged in the 4. 4 checked out. 9 did not. Let's get rid of 9. Just the 4. We're good. That's the only time. That's the only time mathematics where we actually have to plug it back in to check our answers. There's no other way around it.
Why does it happen like that?
Because we technically get rid of, by squaring both sides, we introduce a negative as well as a positive answer to the situation. Okay, that's B. Let's see how much time we have. Okay, and then let's do this one. Yeah, and let's talk about domain. In mathematics, we have 2 problems with domain. And you guys learned it all the way in 3rd grade. First thing is, you in mathematics cannot divide by, thank you, someone's paying attention, 0. Next.
What about 0 divided by 0?
Ooh, that is a calculus question. That's called indeterminate form.
I've
That's
heard
different.
that that's both 0 and 1.
No, it could be any number in the whole entire planet. Just depends on what you're doing it with. Cannot divide it. So it could be 0 and 1, but it could be a whole bunch of things. Okay, cannot divide by 0. We good? Next is
Sorry, it would be undefined, not 0.
cannot take a square root Thank you. Of a negative number. I'll just put number over here. Chicken scratch. Hold on, let me fix it. Negative
I
number.
remember when my teachers told me that you can't subtract more than, or you can't make a number less than 0.
Uh-huh.
That confused me.
My niece was told the same thing in her elementary school. I got a little upset. That's all. Not by much, just a little. Okay, so we're gonna find the domain of this function right here. Find the domain. So first question is this a fraction? Nope. Is this a square root? No. Awesome. The answer is, let me just check because it's written multiple different ways. What do they want as far as domain is concerned? Okay, so you can do it 2 different ways here. You know, let me just check how they want the answer. So we're doing it all the same. This is 1.4.
What is the domain again?
Sorry, Abby, say that again.
What does domain again?
Domain is all the numbers you can plug in into this equation that when you plug it in, you will also get a number out, an answer out of it. So I can plug in anything into this x's and I will eventually still get a number out of here. And so the answer is all real numbers. And I just checked the back of the book because some books, they want you to answer it in, this is called, I don't know, English, answer in English. There's something called inequality notation. There's something called interval notation, which your book is not doing. Say again? I'm not plugging anything in. So I'm just saying, what numbers can I plug in so that I get out a number as well? So how about this? Contrast it with this, Noah. I'm gonna change it to g of x just to have different numbers here. I'm gonna get something looks like this. G of x, how about x plus 4 on top, x minus 1 on the bottom. So notice over here, if I can't divide by 0 in mathematics, so hold on. I can have zeros on top, right? I can have zeros on top of fractions. I just can't have zeros on the bottom. So I don't care about the x plus 4. Who cares about the x plus 4? Oh, that's right. We only care about the x plus 1. Yes, yeah, this one you can do negative numbers because it's talking about a fraction, because this one was talking about square root. And this one's actually talking about division. So one is talking about fractions.
Yeah,
That was talking about
I meant for the specific one, because for some of the ones that we were doing for homework, you had to specify that it was negative.
Give me some more. Okay, go ahead.
Yeah,
As far as it's, you had to specify if it was.
you had to specify the numbers that you could put into the X were negative because the positive wouldn't work, so.
Okay, gotcha. No, because I can still put a negative 12 into here, right? It's just I can't put 1 itself. So all real numbers. And this one is the except x is equal to 1. It's only one little dot that it can't be. Okay, and then let me just throw in a weird one here. How about h of m? I don't know, h of m. I'll go h of m. So we're going to go square root of m plus 17. Yeah. In this case, now it becomes, in fact, you know what? We could do this. Let's see. If you wanted to do it algebraically, like to solve it, you can actually put this guy here set equal to 0. And notice when you solve it, that's when there's your exception. Okay. For this one, what we do algebraically, we say, hey, this guy could be either greater than or equal to 0. We can solve that way. So this turns into an algebra equation here. Subtract the 17 from both sides, and we got ourselves any m. So how about this? All real numbers. No, just kidding. Sorry, guys. Real quick here. So the answer is just m is greater than or equal to -17. Had to throw in one just to mess with you today. Okay, and then how about a fun one here? Let's see if I can figure out a fun one. Oh yes, yeah, absolutely.
When you're excited, that scares me. People laugh.
Z of, I don't know what is the letter that I want to use. Pat, go ahead. Z of Z. No, you can't have the variable and the same.
One.
Z of 1. Okay, Z1.
Oh, I'm saying Z of Z1.
Z of Z1. We'll go with that. That's different. Bummer. Let's see. So hold on. Do we even care about the top? No, it's not a square. It's not. We care about the bottom. Ooh, close. Super close here. How about this? So can x, because the square root is on the bottom, because can the square root be negative? So no, right? Because the square root. Right? Also, it can't be 0 either, right? So notice the contrast. It's an easy contrast. Notice this one is going to be m, or when we just first started saying it, we said m plus 17, it has to be greater than or equal to 0. This one's going to be when z1 squared minus 1 is going to be greater than 0. We're good? Okay, the reason why we take out the 0, because it's in our denominator, right? That's the only change there. So now, do you guys remember solving this anytime before? Not absolutely. We do set it equal to 0. So we go like this. We say it's equal to 0. We've got to figure out the equal to part. And that's going to be, anybody? 3, 3 and -3 actually, right? Okay, I'm going to finish this up real quickly here.
Is there an
So
equation where it's actually impossible for the bottom to equal 0? Like, no number would make the bottom equal 0?
So do you guys remember this? You guys had to do test points between them, and you find out if it's positive or negative. You guys remember that or no? No. Okay. If you do that, you get yourself positive values here. You get negative values here because of test points, then positive values. And we say to ourselves, you know what? This guy's going to be if x is less than -3 or x is greater than +3. We'll finish up with that one. Oh, let me see. The homework, does it have that difficult one in there? It does not. And your guys are out of here.
I like how we won't pass off the guy to say that, and then we will. I didn't know. Am I the only one that doesn't know exactly in class?
So what is the homework? Just the rest of 1.4?